Well, hello everyone, and welcome back to Adrian's Digital Basement. In the 1980s, when computers were becoming a lot more common in people's homes and offices, portable computers started to become important, and initial offerings with portable computers were rather large. But they kept getting smaller, and they turned into what can be classified as a laptop computer, and eventually they started getting really small, like this Panasonic Toughbook computer here, which came out in the 90s, all the way to the computers we have today, which are ultra thin, very powerful, and super light. The thing is, the laptop computers that were coming out didn't always suit everyone because you were pretty much stuck with a machine like this Toughbook that had built-in peripherals and a screen and a keyboard. It made it light and portable, but it didn't give you all the expandability you had on desktop computers. Depending on the kind of work you were trying to do, sometimes you really did need to have full expandability, aka ISA or PCI card slots, to satisfy that small niche in the market. A type of computer existed called the Lunchbox computer, and that's going to be the subject of today's video. This is a Dolch PAC-62, which is a portable computer. I mean portable in quotes. It's quite heavy, but it still is portable. It has a handle on the top, and this thing is designed for professional people who need to have expansion cards, because you can see on the side, expansion card slots, but yet still have a machine that can be carried around relatively easily, has a keyboard and a built-in screen, and has all the power you need to get your work done. So in this video, I want to take a look at this machine, which is quite heavy, holding it up like that. I don't know if this machine works, so we're going to first take a look at the machine, figure out what Dolch and PAC-62 is all about, take this thing apart, see what's inside, fix it if it's not working, because I kind of fully assume that at least the power supply on this thing is going to need to be fixed. I think it's from the early 90s. And once I get the machine working, I'm going to add some expansion cards into this thing because I want to have a machine that's portable and yet still has some cards in it. And maybe we're going to upgrade the processor on it as well. So without further ado, let's get right to it. The Dolch line of computers were really targeted towards professionals, so they were known as rugged computers just due to the fact that they are quite well made, and I think mil-spec is thrown around as one of the qualifiers of this machine. So it definitely occupies a very similar space to the Panasonic Toughbook, and this is a CF27, which I've shown on the channel a bunch of times before. I think the Panasonic Toughbook is a lot more durable than this. This thing could probably be thrown off a building and likely still work. The Dolch, on the other hand, feels sturdy and rugged, but I think this case is still plastic. I don't think there's any kind of metal, and therefore I think if it was dropped at any kind of height, would definitely break this computer. But with that said, I think the Dolch still is a pretty rugged machine, and it's going to survive a lot better than just, say, your typical desktop computer at being thrown around in the back of a trunk and used on job sites. Now, this particular form factor that this Dolch PAC-62 occupies is known as the Lunchbox form factor. I couldn't tell you what was the first Lunchbox style machine, but this form factor was actually somewhat common in the late 80s, and the early machines were 8088s and 286s, often with gas plasma screens, and a very similar form factor to this, where the keyboard covers up the screen for protection and just convenient storage. And a lot of those early Lunchboxes also had a similar expansion capability that this Dolch PAC-62 has. What kind of makes these Dolch computers a little bit unique is they kept making this form factor well past the date that all the other companies had abandoned it and just moved to laptop computers. Now, looking at the side of the machine, you'll notice there's a cooling fan at the bottom. From an expansion capability, there are 6 expansion slots, but the top one is held by what looks like a video card because there's a VGA port on it, and the bottom one has an Ethernet port, and it says sniffer port. We'll get to the reason it says sniffer port in a little bit when we take a look at the brochure for this machine. On the back side of the machine, we have the mains input with a power switch, parallel port, and 2 serial ports. That's all there is on the back for expansion. On the right side, we have just a single 3.5-inch floppy drive, and it looks like at one point this case was designed to accommodate 2 5.25-inch floppy drives, and that's mainly because the PAC-62 that we're showing today is the successor to a long line of these computers that Dolch made all the way back to, I think, a 46 machine. The flip-down keyboard has 2 little tilt feet that you can tilt up for a little better ergonomics, I suppose, and the keyboard on this feels really nice to type on. Typing off to an angle, but that feels excellent. It's definitely mechanical in nature, and when you type on it, there's a little bit of a ringing sound you can hear inside the keyboard case. The cord that comes out of the keyboard feels like a phone cable, but doesn't have a jack on the keyboard side, but it looks like it is just an RJ11, so it does disconnect from the computer. Not sure why you'd want to do that, but I suppose if you wanted to extend this, you could just get a little coupler for a phone jack or phone cable and get an extra cable. The all black color scheme, except for the teal accents on the buttons to release the keyboard and on the logo, the Dolch logo, I think is designed to say, hey, I'm ready for business, I'm all business. And of course, the teal gives away that this is probably from the early 90s. They have a simple power and hard drive LED, and these things look like buttons, but they don't actually push. Not sure if they were used in some other application where they did push in, but down here we have brightness control for the LCD, and these are buttons that do push. And this has that soft touch rubber texture on it. In fact, all of the plastic on the inside has it. Somehow it's not sticky and horrible. It's slightly sticky, but just barely. The computer also has some fold down feet on the front of the machine to tilt the whole thing up at an angle. And it does that instead of having a tilt mechanism on the LCD panel, which is completely different than the IBM P70, which was a similar lunchbox computer, although it was microchannel, a little skinnier, and it had a plasma screen. The IBM computer had a very complex mechanism for the screen, which always breaks, of course. So compared to that, these little feet that tilt up are just a whole lot better. And hindsight is 2020. You can look at which computer has survived and isn't broken, at least physically on the outside, and it's the Dolch PAC-62. Let's take a look at some information online about these Dolch computers. So we'll start with Wikipedia, and it says Dolch Computer Systems, stylized as Dolch, was a manufacturer of high-end ruggedized portable computers for the industrial age. Wow, that is some serious marketing speak, the industrial age. The company was founded by Volker Dolch in 1987 in California. He sold his interest in the company in 1996, but continued to run it until he retired in 2001. It looks like Dolch was acquired in 2005 by Contron AG, and it was sold off, or at least the mobile rugged computer platforms were sold off to Axonix in 2007. I don't know any of these companies. The Wikipedia article is light on details, although it does mention there was a 286, a 386, and a 486. Let's take a look at the 286. I didn't initially find information about it, but there is something there. Ah, okay. You know what's interesting? I have definitely seen clone PCs that came in a case that looked basically identical to this, using a monochrome EL backlit LCD just like this one, and they actually took standard motherboards in there, baby AT motherboards, so you could put basically anything inside of them. I've had a few come through the basement, but I've never shown them on video because they were absolutely destroyed by leaking NiCad batteries and just totally wreaked havoc on the inside. But moving over to BitSavers, there are several documentations about the PAC line. And as I mentioned earlier, it has mil ruggedness. So I guess it's not mil spec, it's just mil ruggedness. All internal components are mounted in a custom designed monocoque alloy chassis that is in turn shock mounted inside an impact resistant molded outer shell. All shock and vibration impinging on the outer surface is damped before it ever reaches any of the critical system components. Designed for abusive treatment, Dolch's PAC series has even passed testing for military transportation specifications. Now, there's a specific brochure for the PAC-60 and 61s, the precursor to this machine, and they're really touting it as a portable network analyzer. I think that goes to why that network interface card that we have in this computer says sniffer port. You'll notice that there are two versions of the chassis, a thick and a thin one. The one we have here is the thick version, which has room for two internal drives, even though it doesn't look like the plate that's on this machine is removable. This has a 3.5-inch floppy drive, but also a SCSI CD-ROM drive. And I don't know if this thing came with software, like Wireshark equivalent software. The Expert Sniffer Network Analyzer is a virtual management tool that helps you fine-tune and expand multi-topology, multi-protocol networks. We can see here with the PAC-60 that the front panel at least looks very, very similar to the one we're looking at today. Take a look at this on the inside of this PAC-60. EISA, extended ISA slots along with VESA local bus. And there's the 486 in some type of zero insertion force socket. On the thinner version of the chassis, it looks like it has a riser card for the EISA slots, and it does have VESA local bus on board. I wonder if this is sporting just a normal motherboard inside there. I'd be very curious to see what we see inside of this thing when we open it. It appears that both the 60 and the 61 were 486 DX266s with the 32-bit ESA slots, and it appears that Dolch was winning PC Magazine Editor's Choice Awards even in 1988. All the way through 1990. I can't tell exactly when this brochure is from. I don't see a year on here, but it's from my understanding the DX266 was released around 1993 or so they couldn't be from before then. And then here's the brochure for the PAC-62 specifically. That is this machine. Looks like it's an ATM and fast Ethernet platform. It says it comes with high-performance 64-bit PCI local bus slots combined with 32-bit ESA slots. That would imply the longer PCI X slots. I think that's what that's called. The specs seem to point out that the PAC-62 has a Pentium 100 MHz CPU and high-performance onboard SCSI 2 and SCSI 3. And one thing that's a little bit of a bummer is that the internal screen resolution appears to be 640 by 480, and that's the 10.7-inch screen. I love this cutaway showing the insides of this machine. So unlike a lot of other portable machines, this thing could accept full-length ISA expansion cards. And for scientific applications, that could be hugely important because a lot of the scientific cards that I've seen, say data acquisition cards, were full-length 16-bit ISA cards, and they wouldn't fit in a lot of these other portable machines that existed. So I think that's one of the things that they were really trying to push with this, that full-length expandability for all of the slots. Then moving on to the PAC-63C, the Network General Sniffer platform. Looks like they gave the case a little bit of a redesign. The screen seems a little larger. They got rid of some of those weird fake buttons that are on the front. And it looks like they upgraded the CPU to a Pentium 166 and they got rid of the onboard SCSI. And then checking out the PAC-64, had a 200 megahertz Pentium. This had the larger 12.1-inch screen. They're still using the same artwork for the cutaway, so I guess internally it's still the same, even with that slight redesign on the front. And this seems to have the 12.1-inch 800 by 600 screen, so it's a slightly better one. Now, what was also on BitSavers was a user manual. Now, it's not clear which one this is for exactly. I mean, we can tell by the artwork that it looks like this machine. The date on the manual is 1993. Let's just skim through this real quick. Probably has a little bit about opening it up, which I figure isn't going to be too hard anyway. Oh, it looks like here you can get either an 86 or 101 key keyboard. Connect the keyboard's coiled cable to the keyboard jack on the left side of the main unit. Figure 1.3. There is figure 1.3 showing a DIN connector. There's a circle on the left side of the computer where that DIN connector would be, but it is permanently covered up. It doesn't even seem like it's a plug or anything. So maybe that's a PAC-62 upgrade where they moved to the RJ11 that fits inside of the little tray where the keyboard clips in. Going further down, the manual does indicate that this is the 46, which either has a 33DX or a 66DX2 with some cache and a UMC chipset. And look at that, there's the motherboard. It looks like a bog standard motherboard. Does that mean that if you have one of these, you could potentially just swap out the entire motherboard? I think so. This looks like it uses a regular AT power connector. Oh, this is actually great because I wasn't sure if we were going to be able to upgrade this thing to faster performance. I would really like more performance out of this than the spec Pentium 100 that's supposedly in it. And look through the rest of this manual. So far, there's just nothing interesting. There's just normal PC clone stuff using video drivers, things like that. But this will be useful to us because this PAC-62 seems to have the same case as the earlier ones. To open the back, we just remove the screws and the back cover comes off. And that seems to be it for the manual. Everything else in here is just run-of-the-mill stuff that we don't really need to look at. So that was enough looking through documentation. Let's open this thing up. Let's see what's inside the PAC-62. I'm noticing a missing screw in the middle. I didn't see that earlier. Now the instructions for the PAC-60 and 62, we were looking at the 46 version. It said simply take off the 3 top screws and then the whole cover should come off. Let's see if that works. No, it's not coming along, but it looks like there's a screw there for these ports. We'll take that off. Okay, 2 more screws on the bottom as well. Maybe they added some additional screws to keep the case on versus that first version. Maybe it wasn't as rugged as they said it would be. So now let's see, with all those off, this should pop. Oh, there we go. Look at that copper coating. Very nice, very high quality looking. There is the computer on the inside. We can see the bottom side of the floppy drive that's right there. We have the power supply, the I/O ports. There is the network interface card down there you can't see. Looks like that video card is there and a retention mechanism for the long cards. Looks like there are 2 screws for the retention mechanism. Let's get those out. Oh, there we go. That just unhooks, lifts away. This thing has a dual Pentium motherboard. 2 socket 7s there. Now, a very low profile and dinky heatsink on there, but my assumption is that was to maintain compatibility with full-length cards that would have run into and conflicted with this CPU if it used a taller cooler. I'm noticing a Dallas clock chip is installed on the board. It looks like it's in a socket, so that'll be very easy to change. And on first blush, this looks like a somewhat standard motherboard. Okay, well that's excellent from an upgradability standpoint, or if it's faulty, That's fantastic. Now notice the ISA slots are brown color, and that's because these are ISA slots, as it was mentioned in the brochure. These are 32-bit ISA slots. They run at 8 megahertz, so they're kind of slow, versus 32-bit slots here that run at 33 megahertz, that's PCI. These are not 64-bit PCI slots. I don't know what it was talking about in the brochure. And here is what is the video card, because it has a VGA connector on it, and this somehow connects up to the front panel. Is it this small ribbon cable that does it? Is it just using standard analog VGA style signaling? And then what are these other two connectors? Is this IDE interface, something like that? Let's take out these cards and see what this video card is exactly. So this is the IDE connection that goes to the hard drive that's already been removed from this machine. And then this connection here is, I guess, for the display panel, because that's it. Those are the only two connections on here. So a Chips and Technologies video card, not particularly performant, especially with this being just regular ISA. That does mean that we could swap out the motherboard again with something else, because it's not using EISA, which is, I don't know, you're leaving a bit of performance on the table. Although some recent testing I saw of ISA slots and video performance showed that the video card didn't seem to be any faster when it was plugged into these slots versus just normal ISA. PCI, on the other hand, would give a big performance improvement. Now, looking at the fact that there's an ALS-245, that's a normal TTL bus transceiver, it makes it feel like this is some type of a digital connection that goes up to the panel. It does say PC video, JP3, but this was not connected to anything. And actually, this says LCD panel. So that must not be for the IDE cable. I guess I just got a bit confused. Now, the reason why I thought it was because this cable seems to go down there somewhere, and I could feel that there was what looks like a hard drive connector. Oh, this is 50 pin. So this is SCSI. Okay, well, I guess this, and I don't know what this one is, but maybe these two together do make up the video connection to the front panel, which tells us that we can't just easily swap that out with something else, unfortunately. If we want to put in a PCI video card and still retain the use of the front screen, which is obviously what you'd want to do with a machine like this. Looks like that is the bezel for the floppy drives. Now that's the power supply that I am the most concerned about, so I want to get this out of the machine, inspect it, check for any bad leaky caps, and replace those if necessary. Sorry, I'm bumping the camera. The fact that the hard drive had been removed from this tells me that someone has been inside this machine. So I have no idea if any of these screws are in the original positions, things like that. Okay, there we go. We get a better view of the motherboard. Let's see, can I pull the power supply connection off? Is this just a normal, yeah, it's just a normal AT power connector. Looks like these cables come off the power supply and probably feed the front panel, I'm assuming. Let's get this network card out of here. It's a Cogent Data Technologies Incorporated EM110TX PCI 10100 fast Ethernet made with a digital chipset. From my recollection, these deck cards are actually relatively decent. I don't see a whole lot of them anymore. From a compatibility standpoint, obviously Intel cards are a little bit more compatible, like just easier to use these days. So it appears our I/O ports are pretty standard affair, so we could plug these into any motherboard. We have standard 72-pin RAM slots, extra SCSI connector, quite a large Intel chipset on this board. And you can see just down there, we have a very standard keyboard jack with a little extension header to go to the RJ11 jack that goes to the keyboard. Totally standard. We could easily just swap this out with any motherboard. That is actually a pretty intriguing thought. I probably should extricate the motherboard from the case as well, so we can bench test this out of the entire computer. Well, OBS just crashed. Hopefully I didn't lose any of the footage, but as you can see, the motherboard has been removed. As we suspected, these two cables were for the front panel, and then there is the keyboard connector right there. And the original motherboard was held in by one nut in this corner, plus a bunch of plastic standoffs, which were a little bit of a pain to get off. Now, oddly enough, this retaining clip for the CPU came off while I was removing the motherboard, but the heatsink is still attached. And that looks like because it is epoxied down. Let's pop this out, see if we can figure out exactly what kind of CPU this is. A0502-100, an SX963. Quite sure that's just a Pentium 100, as was specified. Actually, it wasn't epoxy that's holding this down. It appears to be thermal grease, and it looks like it's leaking out down onto the pins. And there it is. There is the motherboard. Now, who makes this? Is this an Intel part? I'm not sure. There's this cable retaining thing that was stuck down there. 5.4 something or other. 1995 version 2.1, designed in USA. For handling the 8 and 16-bit SCSI connections, we have an Adaptec SCSI controller IC, product affected, and a part number there, 54CO256DE. 54CO, that must be the part number that we can't read under there. Backside of the motherboard doesn't really give us any additional information. Quick search on the retro web for dual Pentium Baby AT motherboards brought me here. In fact, this one looks like it right here. 54CDP. This has the SCSI, and yep, everything else looks exactly the same. I grabbed a few photos front and back of the motherboard so I can upload them, have a bit of a higher quality copy, including the backside. The board that we have here is Rev 2.1. Looks like the one we were just looking at was Rev 2.21. Rev 1.2, 1.2, 1.1, and 1.0. Okay, so this is a variant that may not be documented on here. As far as the video card, this actually does say Dolch Computer System, so this was one thing they actually designed themselves, unlike the motherboard. Now, it does appear that we have the manual for the motherboard. The thing about ESA motherboards is they require configuration disks, even for the motherboard, and I don't see those here, so nothing for drivers, and we have a couple different BIOS options. Dual socket for dual Pentiums, up to 166 megahertz, plus Pentium overdrives. Supports up to 512 megabytes on board, 32 megabyte SIMs are supported. Now this Dallas chip that's on here is not the normal type that's used on other motherboards. That's just a real-time clock with a small amount of NVRAM for holding CMOS settings. This actually has more space in it, 8 kilobytes, for storing the ESA configurations. This is pretty funny. The PDF, I was literally reading it, and now it looks like this. We have a bit of a Chrome problem there. Just refreshing, and it's working again. Very strange. And here's a section in the manual that says, all ESA add-on cards require a software setup. Shipped with the board is a floppy diskette containing the ESA configuration utility and configuration files for the board with the extension .cfg. The configuration file for the motherboard, the 54CDP, is there, whatever, there you go. You should copy all the files with the extension CFG from the diskettes provided by the ESA manufacturers onto this diskette. Turn the system on, you run CFG, and then there's a whole setup process. It looks like a little bit of Googling actually brought me to that file, air0702.cfg. I found a Vogons thread talking about the ESA setup utilities and all the files, but unfortunately they link to things that don't work. They're dead links. Oh, you know what? Okay, with enough searching around, I found an updated link to Mr. Slug's warehouse of all the config files. Excellent. And inside the archive I downloaded, yeah, it just appears to have, I think, a big collection of all these config files for motherboards, but everything else as well. I think the big issue for me, though, is I still need the setup utility, and I don't see it here. All right, Mr. Slug comes through. It looks like the sources link, you click that, and these are the ECU or ESA configuration utility. The whole thing is a bit foreign to me. I've never used ESA motherboards in my life. I don't know if I should use these Air ones. Here's the 54CDP, that's the actual motherboard. All right, I think what it's time to do now is bench test this motherboard. So we'll start first with the CPU removed from the motherboard, and I'm going to insert the postcard. Let's just make sure this thing turns on and we get all the normal voltage rails. We're clearly gonna get 2 dashes without a CPU. That's kind of expected when you don't have the CPU installed. We'll just turn this off and on one more time. Is that the reset line that goes away? Yep, okay. So we'll put this original CPU back in. Let's see if that made any difference at all. No. Oh, yes. So this motherboard has some positives and negatives. Positive is it's dual CPU. So if we're running something like, well, Windows XP or Windows 2000, we will get that dual CPU capability, which should improve the performance on an older system like this. Also, it's cool that it has these ESA slots, but that's also its negatives, in my opinion. The negatives are it's got SCSI and it doesn't have IDE. I would rather just use IDE with something like this. And the ESA slots add extra difficulty because you have to use that config disk and you have to have this special clock chip. So I'm gonna have to Dremel this and add an extra battery on top to disconnect the dead one that's surely inside of there. So I'm not 100% sure if I wanna put this one back into the computer. I'd almost rather put a Super Socket 7 back in there and get the performance boost of having a K62 with the higher bus speeds and whatnot. You know, I don't need the ESA slots. We just have to use one ISA slot for the video card, and then having onboard IDE and a normal clock chip and all the other normal stuff that comes with the Super Socket 7 motherboard just makes life a whole lot easier. This also doesn't have USB. It would be nice to have USB ports on this particular computer, so I have some deciding on what to do. But first things first, Let's test with this strange video card I have. I don't know why it has a right angle VGA connector on it, but it does. Okay, I think we are ready. Let's see if this thing works. Don't have the speaker hooked up or the postcard installed. Oh, there's an LED over here in the corner. It's blocked by the cable. Ah, there we go. Nice. 32 megs of RAM. Ooh, we have the fancy graphical AMI BIOS. I didn't know there was an ESA version of this. So I think everything on here is pretty run-of-the-mill. Has support for IDE hard drives. I suppose, though, we can actually use a PCI IDE card in here to get the fast IDE drive support. And, I mean, that's all there is really to this thing. Let's reboot this computer and see if it says that the battery is dead. Do we have a checksum error? That would indicate that we actually have a bad battery. Control A. That'll take us to the Adaptec host utilities. My assumption is this BIOS is integrated into the main BIOS that's over here. This is standard. If you just plug in a PCI Adaptec card, you get these same exact options here. Exit utility, yes. Now this is interesting, actually. We are not getting a complaint about the battery being dead. And I didn't notice, was the time and date set correctly in the AMI BIOS? Okay, actually, the time and date is fine. Thursday, March 27th, 2025. That's the actual date. And the time says 1:50 p.m. and it is 2 p.m. It's only off by 10 minutes. So whoever last used this thing set the time and date, and somehow it's still working. Now the date that's on the Dallas chip is 1994, 41st week. So this hasn't been replaced. I'd say that's the date of the entire motherboard. That's amazing that this still works after all this time. Absolutely amazing. All right, well, the system is booting up. I want to see if the original video card is working, because this is kind of a deal killer if this doesn't. Now, even though these are ISA slot connectors, they are still backwards compatible with standard ISA. That was a nifty thing about the eISA standard. It just didn't offer the same performance as something like PCI. Okay, here we go, 3, 2, 1, fingers crossed. Get a working system. Come on. Uh-oh. Oh, it worked. Yep, everything looks completely fine. This video card appears to be doing something unusual. It appears to be outputting, I think, text mode in a graphics mode. I think we're actually in maybe 640 by 480. Yes, we are in 640 by 480. It must be doing this because that's the native panel resolution. So I think we can fix the problem with this. Now this is a bit non-standard, which means this will mess up other video cards when I go back to it. But at least now we can see everything. Okay, I have an ISA IDE card with a Compaq flash card on there. I've plugged in an XT IDE BIOS into the machine. And I want to boot this thing into DOS so we can just do a quick performance test on this, see if it's running at full speed. So one thing I'm worried about is that this card is running in graphics mode right now, not text mode. I think that means the performance is probably terrible. Okay, you know what? It's not horrible. 4,700 characters per millisecond for an ISA video card could be worse, to be honest. If I put a PCI video card into the computer like the one we were testing on, I'm sure that's going to be something like 13,000. Let's just do that real quick. Yeah, so 20,000 characters per millisecond compared to what, 4,000 we were getting before? So PCI cards are about 5 times faster. So this is not going to be any kind of gaming rig. It's going to be more for just running utilities and simple things. So the chipset's a 430NX/LX chipset, which I think is the one that supports the multi-CPU operation. And the CPU speed is 73.36. So faster than a 586-133, but slower than a Pentium 133, which of course is completely expected. From a performance standpoint, this thing supports up to 166 megahertz, and I happen to have one such processor that should work in this motherboard. Now there's another variant of 166 megahertz processors, and it's this one on my left hand, but this is an MMX version, which has a core voltage of 2.8, which this motherboard almost certainly does not support. So of course it rules out using the faster MMX CPUs like this 233 megahertz one here, which is the fastest one that was ever made. And of course it rules out using AMD K62 chips in this particular board. Well, I realized something in searching for Pentium motherboards. I don't normally deal with Pentium motherboards, so most of them are at my storage unit. I found a couple floating around here in the basement, including a 500 megahertz Pentium 3 baby AT motherboard. but it's not compatible with the Dolch because the power supply would interfere with the slot 1 CPU that's in that motherboard. So I think this is going to be the best fit motherboard for the Dolch, and I'll have to go find a different one to use on the bench as my test bed motherboard. This has a 200 megahertz MMX processor in here, which I should probably upgrade to a 233. ISA slots for the original video card, PCI slots, and SDRAM, so we can upgrade the RAM. Standard clock battery, and none of the ESA stuff and scuzzy things that this motherboard has on it. And I happen to know this motherboard works perfectly and is ultra reliable. So this is the one that I'm going to put in the Dolch. Okay, things are progressing. So that's the motherboard that I showed. It is now installed in the machine. You can see how much shorter it is. I have the front panel connected up. The video card is in. I haven't tested the actual front panel, so we don't know if that works. Keyboard is connected. I mean, it's all mounted in there quite well. Now, one of the issues I ran into, and I did a test fit, is that this uses SDRAM, and I had originally 256 megabytes of SDRAM in, but the SDRAM modules that were installed were a little too tall, and the power supply couldn't be installed. So I looked through what I had, and I found these low profile ones. So this is currently 96 megabytes of SDRAM, not as much as I was hoping for. I was hoping to run this thing with Windows 2000. This is a 233 megahertz processor, and unfortunately this motherboard, even though it has a clock generator and I installed these clock jumpers, it doesn't really allow me to overclock it. You can typically get these running at 266 megahertz or more without any issue, but we have a slight overclock at 240 megahertz because the motherboard clock controller is actually controlled from the chipset through the BIOS, and 68.5 megahertz is the fastest you can actually go. I did a quick power up with this power supply plugged into the power connector, and I just wanted to see if the keyboard is working, and at least initially the keyboard that's on this computer does seem to work. I could go into the BIOS settings, move it up and down. I don't know if every switch is working yet. I haven't done any further testing, but looks like we're good to go. The next step at this point is to see if this power supply, the one that came in this Dolch, is actually working. I'm going to move the computer off to the side and we can bench test this, see if it's all good, see if the caps are leaking in here, and get this all fixed up. I gotta say that part of me feels like it might be worth just getting rid of this power supply altogether and using a Pico ATX, because with that swap, I'd obviously be able to use that 500 megahertz Pentium 3 in this computer. It means that Windows 2000 would be pretty usable. That would be a good system for Windows 2000. The 233 megahertz processor that's in there now is it's stretching the limit of Windows 2000, to be honest. Now, I just want to mention, if you're working inside a power supply, you have to be very careful. I haven't turned this thing on, and I mean, I've had this computer for years, and I've never plugged it in. So there's no way there's any kind of charge in these capacitors. But if you're working on a power supply, there are some high voltage caps in here that if you just plug it into the wall, they can charge up, and then you can give you a little bit of a zap. So just be careful when you're in here. Kind of a compact power supply. We have a bottom board and another board here. This is probably for input filtering, something like that. A little board there. It's hard to even see down there to see if the caps are leaking. And I think this should come off. There we go. So if there were going to be any refas, it'd be on this board. I'm thinking this is power factor correction, maybe something like that. Kind of gives us access to this board a little bit better. Let's try to remove it so we can look at the back side. That's where the obvious leakage for the caps are going to be. Doesn't look like any kind of cap leakage has happened on the bottom side. Usually there starts to be a whole bunch of corrosion, and it's very obvious because it actually comes through vias and things like that. That doesn't seem to be the case. The most likely caps to leak are these output caps. Small ones might have just sort of dried up. They don't typically leak. And the large filter caps on the input, those are pretty much always fine. Now we have a fan, a Sunon fan. It's probably pretty noisy, so I may end up replacing that since that's gonna make this whole computer kind of annoying to use. So with this power supply, I might just recap at least the output stage here, and that's simply because this thing is from the 90s, 94. It really feels like caps of that era are pretty bad. Let's just take one of these out. In fact, I'm going to take out this black cap and then this brown cap right next to it. We'll just see what those are. I was trying to measure this in circuit. It wasn't really reading with anything. So I'm hearing some sizzling noises removing these. Kind of makes me feel like they've leaked a little bit. I'm not getting the fishy smell that you often get when these do leak. But you never know. Let's just see. Oh yeah. Come on, focus camera. There we go. It just started to leak. 10 volts, 2200. So I just whipped up a little map. I just marked that one so far, and I marked the other 4 that I'm going to take out of the board and where their positives are based on what's actually on here. Let me just whip those out. Right, there's the map. There are the caps I took out. I'm just going to go find some replacements. All right, I ended up replacing these caps here. I just looked around the board and it seemed like there was some more leakage over here, and that one wasn't leaking, but I just swapped it out anyways because it was the same type as these, which were leaking. So yeah, replace those caps. Who knows, the power supply might have worked without changing those caps out, but ultimately when they're leaking, that just causes destruction on the board. It's better just to swap them out. I don't normally do recaps on stuff from the 80s and 70s unless there's obvious problems, but for things from the 90s, everything just went to garbage in the 90s, and therefore, yep, swapping out these caps. There are several little caps on this board. I just left those alone. This thing's probably going to work fine without changing those out, and they're so small they don't normally cause any damage from leaking, if they did leak. So this is going to be dangerous because I'm going to power this up on the bench just like this. I have this hooked up to the 5-volt rail right there, 5 volts. And let's see if this thing works. 3, 2, 1. All right, it's running. That's a good sign. Let's grab the multimeter here. Okay, so we are looking at DC volts. You can just see that there. Let's see if this is 5 volts, how this looks. 5.16, looking pretty good. Let's check the 12-volt rail. It might be a little high because it's not loaded. Oh no, it's fine, it's 12.3. So that's looking good. This is an AT power supply. There's no 3.3 volts on this. This one should be -12, I think, this white wire, or -5. -5, and I think the blue wire here, -12, that's good. This is probably power good. This orange wire should be 5 volts. Okay, power good. Yeah, it looks like this power supply is working. So let's just pull the power cord out of here for safety, let this thing run itself down. I think this thing is good to go and be put back together and go back into the Dolch computer. Now I just have to figure out the jigsaw puzzle of putting this thing back together. We are in the final stretch. I have the rebuilt or recap power supply connected to the motherboard. I also connected the LCD panel power supply cable, which I assume is this 3-pin cable that comes from the front. It's the LCD panel that is the last component that hasn't been tested. So I really have to hope that there's nothing wrong with this. I'm sure it's possible to get to that screen and maybe even replace it with something modern. Perhaps one of those iPad 10-inch LCDs, the ones that have a 2000 by 1500 resolution. They look really good. That would certainly be a big upgrade. All right, here we go. 3, 2, 1. Power on. Okay, it looks like the screen is showing something. It is very, very dim. I'm actually thinking that the backlight might not be working at all. Yeah, I think the backlight is non-functional. Oh no, it's working. Let's turn off some of the studio lights here. That looks terrible. That looks absolutely terrible. Let's see if these controls do anything on the front panel. They don't seem to do anything. I wonder if this is like a software control thing with a special driver. Now, one thing we can tell is that the LCD panel itself, the TFT active matrix screen, is fine. The dimness is going to be caused entirely by the CCFL backlights, the cold cathode fluorescent backlights. They're thin little tubes that run on the edges of the screen. There's some diffusers that will bring the light to the entire width of the screen. And it's unfortunate that CCFL tubes, just like fluorescent tubes and anything else with phosphors, are consumables. They do dim over time, and the longer you use them, the more they dim. I've left the PAC-62 running for about 20 minutes. Nothing has gone wrong. The power supply still is working fine. Motherboard, obviously, I knew worked, and the screen is fine. The backlight, on the other hand, I was hoping it maybe would have brightened up some more. Usually, those types of fluorescent backlights, as they warm up, they get brighter. That has not happened. I mean, it's a bit brighter than certainly when I turned it on initially, where it was basically totally dark. The screen performance on this is frankly very disappointing. And I think it's just a factor that this is just a well-used example of a PAC-62, and the screen just had its life used up. So with all that said, I think I'm gonna install the peripherals that I have for this machine, sound card, compact flash card, stuff like that, put all the ports back in, put the computer back together, so at least I can see this thing fully assembled, and then try to make a plan for what to do about the bad screen. You gotta have some small hands to get all the wires and everything folded up and tucked in underneath the power supply. It's very, very tight there, and I had to kind of give it a big old push to get it to actually go in. But I think everything is mounted and hooked up. So the floppy drive, the serial and parallel ports, the compact flash card is on the bottom. I have the video card moved down one slot, and at the very top there is a Sound Blaster 32 with 8 megabytes of RAM as well. Ultimately, I'd like to add some extra cards to this, like a GPIB interface card, add the USB ports that this motherboard supports, and perhaps something fun like a TV tuner / capture card. Although, again, I think this 233 megahertz processor that's in here is a little bit too slow for that. I forgot to mention that I swapped out the fan and the power supply. There was a little thermistor on this one, so I assume it's some kind of speed control. It did just have a 2-pin connector. I put in a modern fluid-bearing fan into the power supply, so it should be nice and quiet. And since the CPU cooler has a fan on it that's powered by the motherboard, I left the small fan on this side of the case disconnected. I figured that's not necessary. I think it was blowing air directly onto that little heatsink for the Pentium 100, and obviously this machine doesn't need it. So I'm going to wager that this computer is going to be quite quiet. All right, the mains are connected. Let's see if this thing boots to DOS. 3, 2, 1. It's powered up. And yeah, it's very, very quiet. Oh, the speaker works. Power LED is working. Screen is as dim as it was before, of course. 96 megabytes of RAM. It's detecting the compact flash card. I can just barely see that in real life. I think the camera might show it a little bit better. Let's see if this boots to DOS. All right, here we go. It is working. Excellent. We need to check to see if the keyboard is working properly. And what I mean by that is that all the switches are working. Yes, all switches are working properly. I am curious if we test the video with this weird video card, what's it going to do with all these different modes? I think what's kind of curious about this card is since it's outputting everything at 640 by 480 at 60 Hertz, which is the native panel resolution, it gets away from any kind of weird scaling we're going to have. Now, I have a feeling what that means is in 320 by 200 graphics modes, I'm assuming we're going to have 20 pixels at the top and bottom of the LCD panel because otherwise it's going to have to scale it. So it makes the aspect ratio a little wrong with certain games, and we should see that in a second once it switches to graphics modes. The text modes just use a character set that is a little bit more stretched than normal. Okay, the first graphics mode. Oh, wow. I was expecting it to be letterboxed. Doesn't look like it is. Okay, it is scaling the image, and it's doing it with integer scaling. So you notice how these pixels are double thick versus every other one. On a normal non-scaled screen, every horizontal line would be exactly the same thickness. Yeah, kind of like what we're seeing here. This is 640 by 480. Notice how the grid pattern has no extra double thick lines. All right, I have an audio cable plugged into the side of the computer. So there's Fast-Doom running. It's very fast and it's working. Let me turn the sound down. Sound Blaster 32, we have wavetable sound synthesis with that onboard RAM. And then we have full Sound Blaster, Sound Blaster 16, ad-lib compatibility, everything like that. It's a great sound card. Doom looks good, other than the fact that the backlight is just horribly dim. The integer scaling that this graphics card is using is not terrible. It doesn't detract too much from the experience. And then we have Duke 3D, which I know this motherboard can play without any issue. And sound's gonna work, of course, because Sound Blaster 32 just compatible with everything. And this is using wavetable sound. A lot of echo in the music. Nice. Now I know that the video card that's in here has driver support for Windows 3.1. For now, I don't have those drivers, so if you know where the Dolch drivers are specifically for this machine, definitely let me know in the comment section below. I can just run Windows without them though. There it is. I don't have a mouse connected right now. I think this motherboard actually has a PS2 mouse header on it, so I need to find a little bracket for that. I definitely have one. It's just stashed away right now. For now, we're rocking the keyboard, which means I can't really do too much with Paint program, but it's a Pentium 233 running Windows 3.1. It's plenty fast. There it is. The Dolch. It's all back together. And it is good to go. It's better than it ever was with this 233 megahertz processor. Well, except for the fact that the screen is a disappointment. ultimately there's folks watching who probably said I should have left this original ESA motherboard in there. Thing is, I really want more performance, and even the motherboard that I put in here is only a temporary stopgap measure until I can find a Super Socket 7 motherboard that will fit in here properly, so I can really increase the performance far beyond what this original motherboard had. So that's it for this video on the Dolch PAC-62. I hope you enjoyed this PC archaeology episode looking into this machine and realizing that it is fully upgradable. I do plan to do further testing on the original motherboard that was in this machine. ESA slots are very intriguing to me, and if you can believe it, this is the only motherboard that I've ever had come through the basement that's got these slots, and I've never seen one that has PCI and ESA along with dual Pentium. And this is kind of a rare motherboard, and it's pretty cool that it does fully work. As I mentioned earlier, what's left to do on the Dolch PAC-62 is push it to the limit. The motherboard that's in here, I really want to just have as a stopgap. I'd like to get this thing running at 500 or maybe even 1000 megahertz so that it can be truly useful running something like Windows XP. The screen is also the biggest letdown, so I'm going to be investigating trying to figure out how to swap that out. If you have any knowledge about swaps that have been done on these machines, please comment down below and point me to any resources you may know about. I'm really thinking that the 10.1 inch iPad screen might be suitable to swap into this thing, even though the size is not exactly the same. That would be a massive improvement in the quality of the screen. And the funny thing is, that means I could do away with that slow ISA card and switch to something like this oddball S3 card I have with the right angle VGA connector. Because if I'm using something like an iPad screen internally with a little converter board, I'll need to connect it up probably through VGA to a PCI card, and well, something like this, that would actually be perfect. Now, when it comes to the Lunchbox form factor this machine occupies, I think that it's sort of a cool form factor that still has some use today. There is definitely a use case for having a computer that has a bunch of cards in it that you can just pop on your desk, use briefly, and then put away very easily, all in one and compact. I'm curious to know if anyone used one of these back in their daily lives in the 80s and the 90s, maybe as a home computer or as a work computer. I'm actually pretty excited to have the Dolch up and running. I've had this thing for a few years and I'm glad to know that it does work, so you'll probably be seeing it in future videos. So that's going to be it for this video. If you liked it, thumbs up. If you didn't, you know what to do. Huge thanks to my supporters. Their names are going on the side of the screen and make it possible to do this full time. You can become a supporter. Links down below. You know, all the usual YouTube subscribe, thumbs up, blah, blah, blah. So thanks very much for watching. Stay healthy, stay safe. I'll see you next time. Bye-bye.